In lesson 9.2, we're going to learn how to calculate confidence intervals for proportions. And remember that earlier in the course, we've talked about one way that we could measure an athlete's ability is by giving a proportion or a percent based on categorical variables. For example, in baseballs, hitters have a batting average, which is the proportion of hits they get out of their at bats. So, batting average is really a percentage. In basketball, players keep track of their free throw percentages, and this is calculated by counting the number of free throws made out of the total number of attempts. So, anytime we're working with categorical variables, we're essentially summarizing those using percentages. Now, we can never know a baseball player's true batting average because this would involve knowing the proportion of hits they would get in an infinite number of at bats. But we can give a plausible range for their true ability, which would be their actual batting average by calculating a confidence interval. We're going to write down the formula for a confidence interval first, and then we'll run through a couple of calculations. So, this is the formula for a 95% confidence interval for one proportion. So, this would be the case where we're working with just one set of data that we're collecting, maybe one athlete or one team. And the one proportion that we're trying to estimate is P. So, P stands for proportion. And here's what the formula looks like. Go ahead and pause the video and be sure that you copy that down accurately with all the correct symbols. Now, underneath that formula, we're going to identify what all those variables stand for. Now, P, which is the value we're trying to estimate, is the true proportion of successes, which is the athlete's true ability. And like we mentioned, we have no way to estimate that or no way to know that for sure. So we're going to estimate it using our confidence interval. Now, you'll also notice in that formula that you have P with a little hat symbol above it. And that little pointy arrow, we call that P hat. That is the observed proportion of successes. That's the athlete's performance. So that might be one season, one game, or whatever the information is provided to you in that problem. Now, the other variable that's given in there is N, which is the number of attempts, and that's your sample size. Now, you may be wondering why we have the number 2 in that formula, because essentially what we're doing here is we're taking an observed performance, that's the p hat, plus or minus, and this is what gives us our margin of error. So why do we need the 2 in that formula? Well, think back to what we did in chapter 8 when we were talking about a normal distribution. And this is an example of Peyton Manning's passing yards. So it's not really a percentage, but it's kind of the same idea that explains why we're using that too. You may remember that according to the empirical rule, data is distributed in a normal distribution according to kind of a predictable pattern. And we know that we can get 95% of the data if we go out 2 standard deviations from the mean. So the 2 in that formula is guaranteeing us that we are going out far enough from our estimate that we should be getting 95% of the data included. And therefore, we can be 95% confident in our guess at the athlete's true ability based on their performance. So that's why the 2 is in that formula. All right, let's do an example. What percent of baseball fans in New York City are Yankees fans? You maybe know that in baseball, in New York City anyway, there are 2 teams. We have the Mets and the Yankees. So some undoubtedly favor one over the other. Anyway, to find out, we take a random sample of 500 baseball fans in New York City. 267 of them said that they prefer the Yankees. Part A is asking, what is the single value estimate for the proportion of New York City baseball fans who prefer the Yankees? So here we would calculate P hat, which is the value that we get from our sample, and that would be 267 out of 500, which is 0.534. So, in other words, what we're saying there is based on our sample, we're estimating that 53.4% of baseball fans in New York City prefer the Yankees. Now, if we took another sample of 500 fans, would you expect to get 267 who support the Yankees? Why or why not? Well, in this case, I would say probably not because every sample is a little bit different. And you may get some samples that are less than that, some samples that are greater than that. But our idea is that we're going to use this one sample with a margin of error that's hopefully going to be correct 95% of the time. But not every sample is going to give us 267 out of 500. All right, based on our single value estimate, we're going to calculate the 95% confidence interval for the true proportion of New York City baseball fans who prefer the Yankees. So here is the calculation that we're going to do, and I plugged all the numbers in already. The 0.534 is the p hat that we calculated back in part A. And notice underneath the square root, I have 0.534, which is p hat again. And then this 0.466 is 1 minus p hat. And sometimes I like to actually just do that calculation and then plug it in here. And it just makes it a little bit simpler when I go then to evaluate that on my calculator. Now, what I would recommend that you do to calculate this is I would do all of this stuff under the square root first. I would store that answer in your calculator. Don't round it off. Then take the square root. Again, store that answer. Don't round it off. And then multiply by 2. And then I would stop there because that's going to give you your margin of error. So you could then write your interval as 0.534 plus or minus 0.045. And please save all of your rounding off until that very last step. And with proportions or percentages, usually we're going to go to 3 decimal places, just like we do with batting averages and other percentages that we've calculated in this course. So 0.534 plus or minus a margin of error of 0.045. We could write that interval then like this, 0.489 to 0.579. And writing it with parentheses and a comma in between is just another way to write that interval. So 2 different formats there, and there are some others that you'll see throughout this chapter that you'll get used to. Now let's interpret this interval. We would say that we are 95% confident that the true proportion of New York City baseball fans who prefer the Yankees is between 0.489 and 0.579. And again, you'll recognize that format that we used in the first section where we're interpreting confidence intervals, where we state our confidence level, we indicate the value that we're trying to estimate, and we indicate the endpoints of our interval. Now, part E says, suppose the actual proportion of New York City baseball fans that prefer the Yankees is only 43%. Does our interval capture that true value? Well, our interval goes from 48.9% to 57.9%, and 43% is outside of that interval. So here we would have to say no. But we know that if we're only being 95% confident that 5% of our intervals will miss the true value, which this one actually happened to do. So maybe for some reason, the sample that we got that day was just a little bit on the high side, which caused our interval to be off by just a little bit. But again, remember, 95% of your intervals should capture the value. You're always going to get a couple here and there that don't. In fact, it's going to be about 5% of the time. In example number 2, it says, after his first 2 games of the 2009-2010 season, Kobe Bryant had taken 45 shot attempts and made 17. So this is pretty early on in the season, right? It's only 2 games. And so part A, where it is asking us to give our best guess of Kobe's ability to make a shot during this season. Here we would calculate P hat, and that would be 17 out of 45 or 0.378. Now, part B, we can use that to calculate a 95% confidence interval for Kobe's ability to make a shot in the 2009-2010 season. So here's the formula with all the numbers substituted in. Again, I'm using p hat out here, plus or minus 2. And then underneath the square root, I actually wrote it using that formula notation. So I did p hat times 1 minus p hat, and then I divided by 45. And this number on the bottom, remember, is the total number of attempts, which in this case so far is only 45. Now, I would recommend that you pause the video and go ahead and try that calculation to make sure that you can do it correctly and get the correct margin of error. All right, for this interval, I got 0.378 plus or minus a margin of error of 0.145, which gives us the interval 0.233 to 0.523. So notice here I wrote the interval in a little bit different way. I didn't use the parentheses, and that's also okay. Now, during the entire season, Kobe took 1,569 shots and made 716 of them. We're going to use these data now to calculate a 95% confidence interval for Kobe's ability. Again, I'd recommend that you maybe pause the video and try the calculation to see how you're doing with the formula and getting all the numbers substituted in. So here, P hat is 716 out of 1569, or 0.456. Now, when we plug those numbers into the formula, this is what the calculation looks like. Notice that we're dealing with a lot more data here. So the number on the bottom now is 1,569 instead of 45 shots. What happens there when we include that in our calculation is that we get a much smaller margin of error. So our single value estimate is different, but our margin of error is quite a bit smaller. And that's because we're working with a lot more data. So now our interval or our estimate of visibility is 0.431 to 0.481. We can be a lot more precise in our guess because we have a lot more data to work with. So our interval is more narrow, which means it's more precise, and we have a smaller margin of error. Please do homework 9.2 in your assignment packet.